So just to refresh your memory, these are the different types of bias that we talked about. So you can have the sampling bias, voluntary response bias, self-interest study, of course, response bias, perceived lack of anonymity, and we did talk about that a bit extensively, loaded questions, and then non-response bias. So, these would be some of the things that we would kind of have to keep in mind, as we are thinking about, conducting a study, doing a poll, or any kind of research, related to that. So we had looked through all of these examples over here. So just keep in mind in terms of the loaded question bias in this case, sometimes that could be done intentionally, right? So it could be that the pollster is, purposefully saying something in their questions that is kind of, leading the person who's answering. So you can intentionally have a loaded question, maybe by someone who kind of already has an agenda and they're, trying to get specific answers to that. But a lot of times it can actually also happen just because you were not thinking and, we just worded the question poorly, right? So not always it's intentional. And I can imagine maybe sometimes it's kind of hard to distinguish if it was done intentionally or not. The other way that a bias can actually show up is the way you order your questions. So sometimes if you change the order of your questions, that can actually also lead as a loaded question, which can also lead to a biased answer. So if you look at this example over here, they're talking about my favorite finding is this. We did a study where we asked students, how satisfied are you with your life? How often do you have a date? So that was the order of the questions. The two answers were not statistically related. So you could conclude that there is no relationship between dating frequency and, life satisfaction. However, if you reverse the order of these questions and you first ask, how often do you have a date? How satisfied are you with your life? In this case, you're almost creating a relationship between going on a date and, how satisfied you are with your life. And in this case, you may actually end up getting biased responses because if, especially if they don't have a satisfactory dating frequency or something, then that may lead them to think, oh, I'm not very satisfied with my life either. So you can see how just changing the order of the questions can also come across as being loaded questions, which can then obviously lead to bias in your responses. So something to kind of think about, as you're going through these different examples over here. Okay, so that was the last part from the bias discussion. Now let's talk about the different types of studies that can be conducted. So in this one, we are looking at observational studies, which is kind of where our, surveys, polls, those kind of studies fall into. So this can be studies that are basically based on observations or measurements. So in this case, observations may be solicited. So you're asking for the results. And that can be something like, when you conduct a poll or do a survey. Or your observations could also be unsolicited. Basically, if you are kind of like, taking records that are already available and kind of using that to, come up with your observation. So in this case, we could say something like studying the percentage of cars that turn right at a red light. And this is, specifically when there is no turn on red sign. So how many cars are turning right and, what percentage would that come out to be? So in this case, as you're imagining, we're not really asking anybody, right? You're just observing. So you could be standing basically at a traffic light and observing, how many of these cars are going to turn right when there is a no turn on red sign posted over there. So you can have two different types of observational studies where you are specifically requesting for the information, so it's solicited, or you are just making observations where you don't need to, get information from someone or something. So in contrast to the observational studies, we also have experimental studies. And in this case, we're basically talking about it is common to use experiments when exploring how subjects react to an outside influence. So in this case, you can kind of think about, if you're getting some kind of treatment that is being applied to the subject. And, just keep in mind, it doesn't have to be like only humans who are getting treatment. You can definitely do this with, you know, different objects, different items, just depending on what kind of experiment we want to perform. So basically, the idea with an experiment is you are, giving some kind of treatment to the subjects. And then, of course, we are recording what those measurements will come out to be. So in this case, when we are talking about experiments, it's basically important to isolate the treatment that is being tested. So just for some examples based on these experiments, let's take a look at that. So think about, obviously one of the most easiest ones to think about is, of course, working with medicine. So here we're talking about a pharmaceutical company tests a new medicine for treating Alzheimer's disease by administering the drug to 50 elderly patients with recent diagnosis. And then, of course, the treatment over here is, the new medicine, the new drug that is being tested on these recently diagnosed patients. So that would be your experiment, right? We're trying to see how this medicine is going to affect these patients. Another example we're looking at is a gym tests out a new weight loss program by enlisting 30 volunteers to try out the program. So in this case, there's not really, like a medicine, but it's a new, program. So they may be doing some new kind of exercises, maybe some new routine. Let's do this first, then do that, some conditioning, some toning. So whatever that program would be, that is what the treatment is here in this example. The next one is talking about a psychology researcher explores the effect of music on effect by basically measuring people's mood while listening to different types of music in this case. Okay, Sabrina, thank you for letting me know.
So you would say it's what the treatment is, what is being applied, or whatever is being applied to the subjects. So whether it's a new workout program or medicine or
trying to see how people react to music. Yeah, exactly. So, and that's the thing about experimental studies, right? I mean, it can be so varied because the idea is what happens if we try this new thing on you and how that affects you or how you react to it. So that's kind of what you're trying to find out in these experimental studies. So that's the same thing they're talking about here. How does listening to music, affect people's mood? So that's basically what we're trying here as a treatment is the music part. The next example, you will see they're talking about, suppose a middle school finds that their students are not scoring well on the state's standardized math test. They decide to run an experiment to see if a new curriculum would improve scores. So to run the test, they hire a math specialist to come in and teach a class with the new curriculum. And then they're saying to their delight, they see a new improvement in test score. So in this case, the treatment would be the new math curriculum, right? Whatever this new person is coming in and teaching. And it's kind of interesting that they use that example here. I was just listening to the news this morning, and they were talking about how Colorado, they just did a recent test on 8th grade students are testing at 38% on math skills. So we are kind of one of the lower states when it comes to testing on math. So they're talking about, okay, so we know our students are not doing that well in the middle school level. So let's bring in this new curriculum and see how it does. So they're saying the difficulty with the last scenario is that it is not clear whether the new curriculum or the math specialist is responsible for the improvement. Because if they had their existing teachers teaching the new curriculum, it would be different, right? So is it the way the person is teaching, the way they are approaching math? So in this case, because we are not sure if it is the new curriculum or is it the new math specialist who is responsible for the improvement, this is what we call as confounding. And that basically means that you were not expecting an outside factor to affect your study. So in this case, you really cannot say where my success came from. Did it come from the person? Did it come from the curriculum? And we will actually be talking about confounding variables. So not about so much as too many variables, but variables that you were not expecting, which could affect the outcome of your study. So let's take a look at that here, guys. And they're talking about how running into this confounding variables can be a downfall of many experiments, and you may not even recognize it. It is sometimes hidden, so you wouldn't even know you've ran into a confounding variable, which has changed the outcome of your study, of your experiment. So let's take a look at that. So here we are talking about confounding occurs when there are two or more potential variables that have caused the outcome, and it is not possible to determine which one actually caused the result. So, again, is it the new specialist or is it the new curriculum? Which one really caused us to have, the result that we had? So just as examples again, guys, here they're talking about a drug company studies a weight loss pill. A drug company study about a weight loss pill might report that people lost an average of 8 pounds while using their new drug. However, in the fine print, you find a statement saying that the participants were encouraged to also diet and exercise, right? So it is not clear, did the weight loss happen because of the pill? Did it happen because they were also doing diet and exercise? Or, both pills and kind of diet and exercise. So in this case, again, we would say confounding has occurred, right? Because which aspect of this study actually caused the weight loss to happen? And that's why, I am always very suspicious of these new diet programs and diet pills because, obviously never take them on their face value. Another example here, guys, researchers conduct an experiment to determine whether students will perform better on an arithmetic test if they listen to music during the test. So they first give the students a test without music, then they give a similar test while the students listen to music. So one without the music and one with music. So in this case, student might perform better on the second test, regardless of the music. And this could be because, they've already taken the test once and they're kind of more familiar with the test, right? So they've already taken it and they have warmed up to the test. So was it really with music or without music, or because, they're doing it for a second time? So there are a number of measures that can be introduced to help reduce, the likelihood of confounding. And this is where we kind of bring in this idea of a control group. And that can make a lot of difference in your experimental study. So you will kind of see, especially if you guys come across like an article or something, you're reading about this, a lot of times for the experimental studies, they will try to do like the treatment group and the control group. So they can kind of measure, just by introducing this treatment within that one group, how does it affect you? So let's take a look at how this control group thing works. So again, they're saying the participants are typically divided into a treatment group and a control group. The treatment group, as you can imagine by the name, is the one that is receiving the treatment. And the control group, of course, is the one that does not receive the treatment. So you try to keep the groups as similar as you can. Try to keep the subject as similar between both the groups as you can. And then, like we said, one group gets the treatment, the other one does not. So they're saying the groups are as similar as possible, isolating the treatment as the only potential source of difference between the groups. So for this reason, the method of dividing groups is important. Some researchers attempt to ensure that the groups have similar characteristics. And I think this is very, very important to maintain that between your control group and treatment group, you are keeping those similar characteristics. So, try and keep the same number of people with the, gender identity, same number of people over, 50, whatever your criteria for your subject matter might be. But they are also telling us, it can be nearly impossible to control every characteristic, right? Every part of your group. So the idea is try to keep it as similar as you can, but also randomness can help you in that case, right? So try to keep your subjects as random as you possibly can, and that can also help you avoid some of these confounding variables to show up. So just look at these two examples over here. They're saying to determine if a 2-day prep course would help high school students improve their scores on the SAT test. A group of students was randomly divided into 2 subgroups, right? So the first one would be the treatment group, and they were given the 2-day prep course. So that's your treatment group. And then your control group, the second one, was not given the, the prep course. And then, of course, you had both the groups of students take the SAT test. So in this case, you will see, instead of doing like the previous example, where they did the first exam with the music and then they had them redo the exam without music. So they were the same group of people where they did both of those experiments with. But instead of that, by dividing our group of students into 2 subgroups, giving one of them the prep course and the other one not the prep course, and then having them take the SAT, then we would be able to see, okay, so did the students with the prep course perform better than the students who did not receive it? So this would be an experimental study by using both treatment and control group. And then, of course, you can see the second example is talking about a company is testing a new plant food that grows 2 crops of plants in adjacent fields that typically produce the same amount of food. So your treatment group receives the new plant food, and of course the control group would not. So the crop yields would be compared, and by growing the 2 crops at the same time in similar fields, you are obviously trying to control for the weather, but you are also trying to make sure none of the other confounding variables or factors will pop in. So growing them at the same time in similar kind of fields where they produce the same amount of food, but then in your treatment group, you give them the new plant food and the other one does not. And then you compare the yields between the 2 fields and you see, okay, did the new plant food give me more outcome? Did I have a better yield, from that group or not? And that's kind of how we would then be able to see if this new plant food is effective or not. So you guys will see examples like this in your homework also, just helping you kind of break down the observational study, experimental study, with and without treatment and control groups and that sort of thing. Now here's another part of this, and that's kind of the interesting thing about how, as a researcher, you can try to control as many factors as you want, but especially working with humans, there is always going to be something unexpected that can potentially show up. So if you just read this paragraph over here, they're talking about sometimes not giving the control group anything does not completely control for confounding variables. So here they're talking about, suppose a medical study is testing a new headache pill. By giving the treatment group the pill and the control group, nothing. So same thing, right? Give the treatment group the new headache pill, the control group, we would not give them anything. However, if the treatment group showed improvement, would we not know whether it was due to the medicine or just a response that, I'm receiving something, so it's got to make me feel better, right? And that's what we call as the placebo effect. So sometimes when you are told, we're giving you this new headache pill, psychologically, we just tell ourselves, oh yeah, this is working, it's making me feel better, right? So a lot of times, do we know, is it actually the medicine that's working, or is it because we've just told ourselves this is a new medicine, obviously it's going to work really well for me? So then you kind of have to think about, oh, okay, so is that a placebo effect? What is that going to do to our result then? So if you look at the definition over here, we're talking about the placebo effect is when the effectiveness of a treatment is influenced by the patient's perception of how effective they think the treatment will be. So not really because they are getting, the new medicine and they think it's the new treatment that's helping me, but it's just that perception of, yes, this is going to be effective and I'm going to feel better, or, whatever the result might be. So a result might be seen even if the treatment was not effectual, even if the treatment is ineffectual, you may still see improvement in the person's condition. So that's something, kind of one of those other things you have to be mindful of when you're performing these kinds of studies over here. So this example is talking about a study found when doing painful dental tooth extractions, patients told they were receiving a strong painkiller while they were actually receiving a saltwater injection, found as much pain relief as patients receiving a dose of morphine. So just because they were told that they are receiving a strong painkiller and all they received was a saltwater injection, the effect that they felt of the pain relief was as if they had been giving, a dose of morphine. So that's what placebo effect does. But Terry, at the same time, isn't it better to have that placebo effect than actually give you some kind of medicine and put some more chemicals in your body? So I think if it's not harmful, I think it's okay. But yeah, you can kind of get into some of those ethical questions in that case then. And, obviously we're not going to worry about that, but it can definitely kind of go off on should they be allowed to do that or not. But we do that, right? I think this is just human nature of how we work with placebo effect. And they're just showing you how something as basic as this can also show up as something that can deter the results of our study that we're trying to perform. So it's just really, really interesting how scientifically we can try to control as much as we can, but there's always something that can show up there which can, affect the results of our study. So to control for the placebo effect, a lot of times, you'll talk about how in these, especially like medical treatments, they will do the placebo pill or the dummy pill. So the idea is in that case to avoid the placebo effect, to get around this idea of the placebo effect, even to the control group, you would give them a placebo or a dummy treatment. And in this way, the idea is then both groups know they are receiving something. They just don't know which one is actually getting the real medicine and which one is getting like a sugar pill, right? So that's how we try to work around the placebo effect. So that way the control group is also getting a pill, but it's not the real medicine. And then the treatment group is the one, where they're getting the real headache medicine or whatever the case might be. And that's how you control your placebo effect. So just to separate between when you are doing that, when you have a experiment where the control group is being given a placebo, you would specifically call that a placebo controlled experiment. So just to kind of differentiate between, is this just a regular experiment study? Is this a study with a treatment group, control group? And then is the control group also getting some kind of a dummy pill or dummy treatment? And that would be called the placebo-controlled experiment. So again, just examples over here, guys. So they're saying in a study for a new medicine that is dispensed in a pill form, a sugar pill would be your placebo, right? So one group gets the real pill, the other one gets the sugar pill. In a study that is doing the effect of alcohol on memory, a non-alcoholic beer might be given to the control group as a placebo. So we know that since it's a non-alcoholic beer, they're not going to have the same effect as the other treatment group who would obviously be drinking alcohol then to see how it affects their memory. In a study of a frozen meal diet plan, they're saying the treatment group would receive the diet food. The control group could be given, just your regular standard frozen meals, just without the original packaging, so the people don't know, which exact brand or food they're eating. So that would be your placebo then, right? So the treatment group would actually be getting the, the actual diet meal, but then the control group would be getting just regular standard frozen meal. So that's how you would control the two groups. We're also talking about, in some cases, it is more appropriate to compare to a conventional treatment than a placebo. So here they're talking about, like in a cancer research study, it would not be ethical to deny any treatment to the control group or to give a placebo treatment, right? So that would be kind of a different type of study. So how would you deal with that? So in this case, they're saying the currently acceptable medicine would be given to the second group called the comparison group. So in this case, it would be a little bit different because you would not be giving them a dummy treatment or like a sugar pill. For the SAT test example, they're saying the non-treatment group would most likely be encouraged to study on their own rather than asked to not study at all. Because, again, you do want to have a good comparison between the students who did the prep course and students who didn't do the prep course. So you, again, wouldn't want the students to just show up to the exam without being prepared for it, right? So they don't get the prep course treatment, but they are still asked to study on their own and at least try and prepare for the exam. So that would be kind of one of those placebo treatments, but not really, where we're saying just don't do anything at all. So you do have to consider the ethical ramifications. And this is kind of, Terry, what I was telling you earlier. So you do kind of have to consider those ethical ramifications. But, again, a lot of times that kind of becomes a bigger discussion. And, obviously, we're not getting into that part of it. So, but just something to be aware of as you guys are looking through these examples here. Now, another term that you guys may or may not be familiar is the blind or the double-blind studies. So this one over here, of course, when we're talking about a blind study, it's the one that uses the placebo, but the participants do not know whether they are receiving the treatment or a placebo, right? And the reason for doing a blind study again is to avoid that placebo effect. Because, okay, let's see you are the control group and they tell you, oh, you know what, you guys are just getting the sugar pill. How do you think that's going to affect on our psychology, right? We're going to be like, oh, well, I know I'm not going to feel good. I know I'm going to feel crappy because you're giving me a sugar pill and not the real medicine. So again, to avoid that placebo effect, you normally do want to do a blind study and not tell either the treatment or the control group what they are receiving, because you again want to avoid confounding variables. You want to avoid placebo effect. Now, when we talk about a double blind study, this is where the subjects and even those who are interacting with them don't know who is in the treatment group and who is in the control group. So even as the researcher, you wouldn't know if this person is in the control group or the treatment group. In the blind study, it's only the people who are in the study don't know if they're receiving, treatment or a placebo. But in a double blind, even the people who are interacting with the subjects wouldn't know who these people are or which group they belong to. It would really only be very few people at the top who are actually conducting the research who would know. But on the normal everyday interactions, those people would have no idea which group these people belong to. So just as an example here, guys, we're talking about in a study about antidepressant medication. You would not want the psychological evaluator to know whether a patient is in the treatment or control group, as it could potentially influence their evaluation, right? So this would be an example of a double-blind study. So even the evaluator who's meeting with these patients wouldn't know what group these people belong to. Because you know what? Even as the evaluator, you could bring in your own biases, right? You could bring your own bias based on what treatment this person was receiving. So again, you kind of have to watch out for that also. So these were just basically highlighting all the different types of studies we have. So remember, you have the observational, the experiment. Where did we go? There it is. So observational studies, experimental studies, then breaking the experimental studies down into treatment and control group, watching out for confounding variables, watching out for the placebo effect, And then, of course, the last part was talking about blind and double-blind studies. Now, the last part here, guys, we want to talk about is the margin of error and confidence intervals. And I had kind of brought this up when we had first started talking about chapter 3. So anytime you are conducting a research or a survey, and we were talking about how USA Today does those daily polls in there, they always mention what kind of confidence interval, or for that matter, margin of error, a study might have. So we're basically saying even when a study or experiment has successfully avoided bias and has been, done really well, there can still be an element of variation. So they're talking about if we took 5 different random samples of 100 college students, and this is kind of going back to the original experiment we had talked about, is how much are they paying for their textbook. So they're saying even if you did 5 different random samples of 100 college students and calculated their average textbooks cost, we wouldn't expect to get the same exact average for each sample, because it's 5 different group of 100 students, so it will always come out to be a little bit different. They're not always going to come out giving you the same average cost. And this is what we call as that can happen from the sampling variation, because you do have 5 completely different groups of people we're talking about here. So to account for these kind of variations, we bring in this idea of margin of error. So the researchers will publish their margin of error, or they will publish a confidence interval for their statistics. So these numbers, margin of error or the confidence interval, basically they describe the precision of the estimate of your confidence level. So we're basically saying, if we say there's a margin of error, and look at this paragraph over here. So if they are saying the candidate has 54% of the likely voters, plus or minus 3%, that plus or minus 3% is the margin of error that we are talking about. So what that means is, even though we are saying 54% of the likely voters are going to support this candidate, from that 54%, you are adding or subtracting 3%. So that means we can say anywhere from 51 to 57% of the voters are going to support this candidate. So the plus or minus becomes your margin of error. And then when you add and subtract that number from 54, this becomes your confidence interval. So somewhere between 51 to 57 of the percent of the voters, we can say with certain level of confidence that this candidate has the support of anywhere from 51 to 57% of the likely voters. So that's your confidence interval. And they're basically saying, the way you write this out is you put them in parentheses from smallest to largest and separated by a comma. So this is how you would write your confidence interval out: 51% to 57%. Now we also have different levels of confidence intervals. So you will see a lot of times they use 90% confidence interval, 95% confidence interval, or 97% confidence interval. And 95 just happens to be, kind of that soft, good spot where most of the confidence levels are going to be at 95%. But remember, you can be at 90% or 95% or 97%. Every now and then you may also see a 99% confidence interval. So the idea is, the higher your percentage for confidence interval is going to be, the higher your margin of error will also be. So you kind of have to be careful about what level of confidence you want to go for. So like I said, that sweet spot is kind of right at 95%. So we are saying that every time, if the poll was conducted repeatedly and we made a confidence interval each time, we would expect the true percentage, or that parameter, to fall within our confidence interval of 95 out of 100 times. So, we would basically say, yeah, this is kind of where you're going to land. Your true percentage for 95 out of the 100 times is going to fall, at 54%, or, that 51 to 57%. So as many times as you keep repeating it, you should kind of stay within that percentage area that you were at. So in this case, they're really not getting too detailed into calculating the margin of error or the confidence intervals. So we will get into that a little bit, but we're going to wait for this after we get done talking about the other concepts. So they're just introducing this concept of the margin of error and confidence intervals here, but we'll look at their calculations later on. So just kind of keep that in mind as you move forward. So this last example here is talking about, let's say we asked a random sample of 100 students at Portland Community College and found that they spent an average of $451.32 on their books their first year, plus or minus $85.63. So write this as a confidence interval, assuming a 95% confidence level. So let's take a look at that. Oops. What that would end up looking like. So of course, if you're talking about the initial dollar amount as $451.32, and then this is the plus or minus, then, of course, then you subtract and add that number to your 451.32, and you can see your confidence interval would be going anywhere from $365.69 to $536.95. And again, writing that as a confidence interval, that's what this guy would end up looking like. So instead of giving you a percentage, this example was showing it to you with the dollar amount, right? But it's still the same idea, same concept that you are going for. So we are basically saying, if you kept taking a random sample of 100 students from PCC and you kept asking what their average cost was, every random sample that you choose of those 100 students is going to land somewhere between these two values. And we are saying we would be 95% confident that the average price of the textbook cost is going to go anywhere from $365.69 to $536.95. So like I said, the last part of your homework in 3.1 is actually going to be focusing on the types of studies, so observational, experimental, those kind of studies. And then the other concepts we looked at, and then the very last part is where you will see similar examples like this, where they're talking about the confidence interval. Let me see. Let's take a look at this example here, actually. Okay, Sabrina, that's fine. So let's look at example 20 over here, guys. Okay. So this is talking about for clinical trials of a weight loss drug containing Garcinia cambogia. I don't know. The subjects were randomly divided into two groups. The first received an inert pill along with an exercise and diet plan, while the second received the test medicine along with the same exercise and diet plan. So basically, they're telling us the first group basically received the placebo pill. The second one actually received the drug they were testing, and the same exercise and diet plan. The patients do not know which group they are in, nor do the fitness and nutrition advisors. So let's identify which one is the treatment group over here, guys. The second group, Terry? Yeah, very good. So it's the second group. With the test medicine. Okay. Which is the control group if there is one? That's the first one, yeah, receiving the inert pill. So what kind of study is this? Blind, double blind, neither? Yeah, very nice, Terry and Amanda. Michael, very good, because they're specifically telling us the patients don't know which group they are in, and nor do the fitness or nutritional advisors. Perfect. So this would be a double blind study. And then the last one, is this best described as an experiment, controlled experiment, or a placebo-controlled experiment? Okay, so let's see. I've got Amanda with controlled. Terry, you said placebo-controlled, and Michael, you are also saying, yeah. So guys, since that first group is receiving an inert pill, yeah, so inert basically means it's not going to have any effect on the person. It's basically sugar pill. So in that case, yeah, it makes it a placebo controlled experiment. So yeah, very nice. This will be placebo-controlled experiment. Perfect. So yeah, these are the type of, a couple of your questions are going to be just identifying like what kind of study you're doing, what kind of type of experiment and stuff you're looking at. All righty, good job, guys. And then the other one I was looking at, let's look at 24. So this guy is talking about a poll found that 38% of US employees are engaged to work, plus or minus 3.5%. So what's your margin of error in this case? So a poll found that 38% of US employees are engaged at work, plus or minus 3.5. So they want to know what is our margin of error here.
Are we subtracting the 3.5 or adding the 3.5 to the 38%?
Not for the margin of error.
Okay.
So actually, Michael, looks like what you gave me was the confidence interval, I think. Amanda, you said 8%, Michael 7%. Actually, guys, the margin of error is 3.5%. So when they give you that plus or minus, that's your margin of error. So for the confidence interval, Terry, that's where you add and subtract. So now they're asking you to write the results as a confidence interval. And remember, you write your confidence interval in parentheses, separating the two values using a comma. You write the smaller one first and then the larger one. So let me see what your notation for the margin of error will look like in the confidence interval. And I will be right back, guys. I'm going to go shut my door because it's freezing me over here. I had kept it open for some fresh air, but it's too cold. Yeah, so actually, Michael, you don't put it with a hyphen. You have to put it in parentheses, separated by a comma. Because since it is an interval, you basically put the smaller value and the highest value, and the idea is it will be anything. Exactly, Amanda, that's the right way. So you put it in parentheses, separated by a comma. So that would be like you guys have the right number. So that would definitely be the 34.5% for the first one. And then of course, the other one is where you add, and you guys had 41. Hold on. 41.5%. So yeah, basically just take the 38 and subtract 3.5, which will give you the 34.5, the lower limit. And then with 38, add the 3.5, which of course gives you the 41. 0.5. So that's how you write your confidence interval. Now, the last part is asking us to explain what the confidence interval tells us about the percentage of US employees who are engaged at work. So how would you kind of explain that part? Yeah, Terry, very good. Yeah, so just the smaller number than the larger number in parentheses separated by a comma. Perfect. So remember, your confidence interval is going from 34.5 to 41.5%. So we would say, and remember how they said 95% was the common level of confidence interval. So we would say we are basically 95% confident that 34.5% to 41.5% of US employees are engaged at work. So that's kind of how you would write that out. Go ahead, Terry.
Where do you get the 95%?
Because they told us that the most common level of confidence we are using is 95%.
So we're just gonna assume that it's 95% with.
Yeah,
most-
because they're not telling us otherwise. So we are going with that assumption. So right over here.
Okay, thank you.
From here. Yeah, that's just where I'm getting it from. So this was what, number 24? Yeah. And you know, if you don't want to use the 95%, you can always say we are confident that 34.5 to 41.5% of the US employees are engaged at work. So you can leave that out since they didn't specifically tell us what the confidence level was in here. Any other questions, guys? And you know, of course, you can see there are a whole types of examples in here that you can kind of work through, and you will definitely see some of these similarities in your homework examples too. So let's go ahead and move on to our next section here, where we're now getting into, you know, organizing our data. So you can kind of see what the different breakdown over here is, but let's get into what type of data we have. So here we're talking about, you know, once you have collected your data, and this could be from an observational study, or it could be from an experimental study. Now the idea is, okay, so we have all this raw data with us. Now what do we do? You know, what kind of information are we trying to gather from this data? So this is where the idea of summarizing and presenting your data in a meaningful way is coming out to be. So, you know, to summarize and present is where we then start looking at tables, graphs, you know, charts, and that kind of thing, which is where we are heading into in this chapter over here. Sorry, section over here. Oh. So let's talk about the different types of data over here. You have categorical and you have quantitative data. So when we're talking about categorical, which normally we actually call it qualitative. So qualitative data are the pieces of information that allow us to classify our subjects into various categories. So you're able to put them in categories. So here we're talking about, we might conduct a survey to determine the name of the favorite movie that people saw in a movie theater. So when we conduct a survey, the responses could be, you know, obviously the names of the movies, Finding Nemo, Black Panther, Titanic. So we can count the number of people who give each answer, but the answers themselves do not have any numerical values, right? Because we're just saying, well, 20 people like, you know, the Black Panther. So this is what we would consider as a qualitative or categorical data, because your data itself is not the number. Your number is, oh yeah, 20 people said they liked, watching the Black Panther in the movie theater. The quantitative data, on the other hand, of course, would be numerical, right? Because that's the quantity. You can calculate something. So these would be responses that are numerical in nature and with which we can basically perform some kind of meaningful calculation. So just remember, those are the two different categories of data that we can collect. A survey could ask the number of movies you have seen in a movie theater in the past month. And so in this case, since you are asking them how many movies you have seen, this would be an example of quantitative data. If you ask them what was your favorite movie to see in a movie theater, that's your qualitative data. So that's the two different things you kind of have to keep in mind here. And then they're talking about some other examples of quantitative data would be how long is the movie? So what was the running time? So again, that would be numbers, 104 minutes, 137 minutes, or how much did you pay for the movie ticket the last time you went to the movie theater? So that again would be numerical, your dollar amounts. So we cannot assume that all numbers are quantitative. Sometimes it is not so clear cut. So in this case, where you have numbers, but they're not really quantitative data. So, gathering zip codes in the survey to track the geographical location. So yeah, zip codes are numbers, but you can't really just, add all the zip codes and get some number from it, right? Because zip code is just to identify a location, a geographical location. So again, you wouldn't be able to really treat them as a quantitative data. A survey about the movie you saw most recently. So if you broke it down into how would you rate the movie, and you're saying, okay, option 1 is it was awful, option 2 is it was just okay, option 3 I liked it, it was great, best movie ever. So 1, 2, 3, 4, 5 are just listing the options, right? They're not actually numerical in nature. If somebody said, oh, okay, I would rate this movie as 4, it was great, I can't really use that because they are just saying it was a great movie. So again, this is not a numerical data. This is not quantitative. So that's kind of what they're trying to highlight in these two examples, is they may be numbers, but that doesn't make them quantitative data by default. So something to, again, watch out for. So they're talking about look for the purpose of the study for any variables that can be classified as categorical, which is again qualitative or quantitative. Another thing to consider is, what are you going to do with that data now? So I have collected all this raw data, whether it is categorical or quantitative, what do we do with it? So let's start out with the categorical or the qualitative data. Since there are no calculations that can be done, we will start summarizing these by putting them into tables. So you can do a frequency table or a relative frequency table. And that's probably one of the first things we do is whenever we start working with raw data is try and put it, in some kind of a organized format in categories. So one column for the categories, another for the frequency, or, basically how many times did somebody choose that movie as their favorite movie? So how many times did that category occur? So this example here is talking about an insurance company determines vehicle insurance premiums based on known risk factors, right? So if a person is considered a higher risk, they will obviously be paying higher premiums. And, they do that with younger drivers, right? Because they're new drivers, they're just learning how to be on their own, drive confidently. So younger people will always pay higher premiums. And then as you get older, your premium starts going down. So I'm sure you guys have seen that yourselves, or your parents have, or if you have kids, you paid insurance for, you would have noticed that also. Now, one potential factor is also the color of your car. The insurance company believes that people with some color cars are more likely to get in accidents. To research this, they examined police reports for recent total loss collisions, and here is the data. Now, I don't know if you guys have heard this or not, but when I lived in Kentucky, people would tell me this all the time. Apparently, red cars get pulled over more than any other color of the car. I'm still not sure why, But apparently, if you drive a red car, you have likely higher chances of being pulled over, getting a ticket. And a lot of you guys are nodding, so I'm guessing this is something maybe you have either experienced or heard. Yeah, exactly. So let's stay away from those red cars, right? Go ahead, Terry.
I was going to say a poll could be taken on how many red cars are actually sold compared to other colors of cars because of that.
Yeah, exactly. So every time I see somebody driving a red car, I'm like, oh, I hope you're not getting pulled over today, buddy. So just from the poll that they have done based on the car colors and how many total loss collisions these have had, you will see they're, of course, breaking it down by the category. So that would be the color. And then on the right-hand side is that frequency we were talking about. How many times did that category occur? And in this case was how many total loss collisions did blue cars have? So you can see you've got 25, 52 for the green, 41 for the red, 36 white, 39 black, and then 23 gray. So it's kind of interesting that your total loss collisions had the highest frequency for green at 52, and looks like gray was the one with the lowest frequency where they had lesser total loss collisions. So again, this is a good way because, if you just had raw data and not organized, then it would be kind of hard to see, well, okay, how many cars were actually in that total loss collision category, what they belong to. So organizing your data is probably going to be, a crucial step when it comes to conducting any kind of study. Just getting the answer from the people and, doing the survey is really just the very beginning. There's so much more you do after that. So that's your example of a basic frequency table over here, guys. Some textbooks will also call this a frequency distribution table. This textbook, of course, is just calling it a frequency table. And now, what does a relative frequency look like? So the thing you need to remember about relative frequency is that it's basically a percentage for your category. And the way we calculate a relative frequency is you take the frequency for each category. So what was the frequency for blue cars, for green cars, for red cars? You take each of those individual frequency and then divide it by the total of your frequency, which in this case comes out to be 216, right? So you will take each frequency for each category of your car and divide it by the total. So you will see 25 divided by 216, 52 divided by 216, same thing for each one of these individual categories. And then you can leave it as a decimal answer, or you can convert it as a percentage. But normally for relative frequency, we do actually leave it in decimal form. But here, like I said, they're also converting it to percentage, which is totally fine. Now, because of rounding errors, sometimes it's not necessary that when you add up your relative frequency column, that it would add up to 100%. It should, but it sometimes will not. You may get like 99.99999 repeating, right? So it may not be 100%, but close enough. Every once in a while, you may go like 100 plus a little over, right? So 100 point something left over. But as long as you are really close to that 100%, or in decimal, that would be 1. If you're close to that, you're fine. Because like I said, with rounding errors, sometimes you're not going to get exactly, a total of 100, which is fine. So getting your data into a frequency table or a relative frequency table is great. But then, again, we kind of want to go further and maybe put this in a more visual, graphical format. So then we can start talking about how to put this in graphs and charts. Yeah, so for categorical data, we can definitely use something like bar graphs or pie charts to help us out. So let's take a look at what a bar graph would look like. So again, your categories are the color of your vehicle. So you can see how this one has been set up as, your different colors on the x-axis, the horizontal axis. And then on the y-axis, we put that frequency. So remember, your lowest frequency was 23. Your highest frequency is 52. So you want to make sure, you get all of those numbers in here. So you will see our frequency axis, the vertical y-axis, has been started at 0, and we go all the way up to 55. So we can make sure that that 52 has a place to go in there. And then based on the frequency, you of course get the height of your bars. So how tall is your bar going to be is going to be based on the frequency for that category. And in bar graphs, guys, you do actually have that little gap between each of the bars. If we were talking about a histogram, we don't keep any gaps in between, but you can't really do a histogram for a categorical or qualitative data. We do histograms when we're working with the numerical data, so the quantitative. So a bar graph, you will definitely see these little spaces between each of the bars. And here they're just talking about a bar graph is a graph that displays a bar for each category, which will be with the height of the bar, indicating what the frequency of that category is. So you can actually do vertical bars, but you will see there's horizontal bar graphs also. So you can convert this into a horizontal one. These guys just went with vertical. So your horizontal axis is where you would have the categories, and vertical axis is where you would put the scale for your frequency or relative frequency. So categories on the horizontal, and then frequency or relative frequency on the vertical. And then, like I said, since your highest frequency was 52 for green cars, make sure that your scale on the vertical axis will accommodate that highest value. So that's why we went from 0 to 55, and they're just breaking it down into a scale of 5 units each. So 0, 5, 10, increment of 5 units each. So you can obviously draw, bar graphs by hand, but you can also use technology. And then never ever turn in a graph, guys, without any labels, without any title. So make sure you always put labels. You put a title, so you can see in this graph over here. Let's make this guy bigger. You'll see they've given us a title. So that's the vehicle color involved in total loss collision. So we know we're talking about vehicle colors, and that's what the x-axis is with the colors. And then the frequency, of course, is telling us how many of these vehicles were involved in the total loss collision. So you want to have labels, you want to have a title, and then you will see how on top of each graph, they have actually, each bar, they have also put the frequency number so that you can see, yeah, okay, there were 25 blue cars that were in the collision, right? There were 41 red cars that were involved in the collision. Sabrina, so yeah, I mean, you can kind of do the bias in the graphs. Also, I'm not sure if this textbook goes over that bias or not, but you can definitely introduce bias even in charts. You actually see them in sometimes. So in this graph, you will notice how the thickness of our bars is the same for all of them, but sometimes they will actually do that. They will make the bars thicker or thinner just to kind of emphasize. So you can definitely put a bias into a visual chart also. Yeah, if you find that clip, please, yeah, send it to me. I would love to see like what they're talking about in that. So it is so funny that you mentioned that, because bias can literally be put into anything in statistics to kind of, divert that person's mind over something that, they want them to focus on something completely different than what we're talking about. So we will definitely get into how to use spreadsheet and how to do some of these graphs, guys, especially for something like a pie chart. Doing this by hand can be actually quite tedious, but then using technology makes it go very, very smooth. So we'll get into that next time, is talk about how to use our spreadsheets to make these charts and graphs, and you can kind of see some examples over here. And then Sabrina, not exactly biased, but you can see how they are talking about misleading information in graphs. So we'll get into all of those discussions, guys. So that's kind of where we're headed. So we'll start right over here by designing our own graphs and the pie charts. And then as I was telling you guys last time, it's going to be I keep saying chapter, I'm sorry, section 3.3, where we'll actually start getting into calculations. So we haven't really done any calculations so far, but 3.3 is where we start getting into measures of central tendency. So that's where we'll talk about, like the mean, median, mode, and those kind of things. So calculations will begin in section 3.3, but next class we'll talk about how to use technology to make some of these graphs, okay? So if you guys have any questions, please stay back and I'll be happy to answer. And then I'll see you guys on Wednesday. And again, your 3.1 homework is open, guys, and I'll go ahead and open 3.2 as soon as I'm done with our class, okay? All right, guys, have a wonderful day. I hope it'll stay warm enough. Take care, everyone. Bye. Take care. Bye, Michael. Aw.